Hi, good morning everyone. Today is our first lecture of algorithm analysis subject. Please try to understand everything I teach. If you have any question, you can stop me at any time and ask. I will also be asking you questions. First, try to understand what an algorithm is. It is a step-by-step procedure to solve a problem or a task in a finite amount of time. Most algorithms transform input objects into output objects. The input takes a set of values, the output produces a value or set of values. Let's consider a very simple example, such as sorting exam marks of algorithm subject. A is an array of unsorted marks. We can develop an algorithm or step-by-step procedure to sort this array in ascending or descending order. Let's consider another exciting example. Self-driving cars or driverless cars or robotic cars, which are capable of driving without human support. I will give you a quick explanation about this scenario. There are many sensors installed in these cars. These sensors sense its environment, so gather information about all the moving and stationary objects around it and collect data. All these are happening in real time. So every millisecond or microsecond, these sensors transmit and receive data. Then this data will be processed in a cloud server or in a dedicated server. Use decision making algorithms to make an intelligent decision about perfect positioning of the car, when to stop the car, when to take the turn, which degree, etc. It calculates and takes real time decisions. Please try to understand the concept of algorithms with this example. We have real-time sensor data. We have an algorithm to make the decision about perfect positioning of the self-driving car. For a program, algorithm as well as how we structure the data is very important. We will discuss the data structure in another day. Let's focus specifically about the algorithms. I will divide this classroom into four groups. I will ask you to develop an algorithm, each group separately, to take a decision about perfect positioning of self-driving car. Let's assume you all did a great job and gave me four perfectly working algorithms. Now, the issue is how do I differentiate these algorithms? Some algorithms work fast while others work slow, depending on how you structure your algorithms. Therefore, estimating running time is important. Running time of algorithm increases with input size, hence it's a function of input size. Average time is usually difficult to determine. We also want to estimate on the worst case running time, as it is crucial to some application where time is a critical factor, such as self-driving cars, robots, games, etc. We use real-time data and have to take a real-time decision. So accurate decision with right time is essential, otherwise you will crash with another car. Now we know estimating running time is so important. This running time is bounded by two linear functions, fastest primitive operation and slowest primitive operation. So running time of your algorithm cannot go beyond these limits. To run this algorithm, we need resources, memory, communication bandwidth, computation time, usually the most essential thing. Now we have four working algorithms developed by you. Let's try to analyze together which algorithm is the best. As said before, if you do not understand at any point, please stop me and ask. I can clarify it. Before knowing which algorithm is the best, we need to know why do we need algorithm analysis. Writing a working program itself is not good enough. Programs should work efficiently. If the program is running on a large data set, then the running time becomes an issue. So consider all possible inputs. Characterizes running time as a function of input size. In order to compare algorithms, the same hardware and software environment should be used. Here we assume parallel computers are not used. In other words, instructions are executed sequentially. We have four working algorithms developed by you how to make decision about perfect positioning of a self-driving car. Now you know why it is important to classify these algorithms. We use something called beacon notation for this based on their running time or space requirements. Let's have a short break and go through these techniques to see which group developed the best algorithm to make the decision about perfect positioning of a self driving car. See you after the break.